In this video, we are looking at combinations. In the last video, we looked at permutations, and so this video, we are now looking at combinations. We saw that in permutations was a selection or an arrangement of objects where order was important. A combination, as opposed to that, is a selection of things where it doesn't matter what order they come in. I've always found this interesting that this thing here is called a combination lock, but really it's not a combination, it's a permutation, because the order that you choose those numbers in, or you select the numbers, makes a difference. You can't just pick any three numbers and it work. They have to be in the right order. So combination is one where order is not important. Let's take a look here at the bottom. I've got a bunch of things. If you wanted to pause and see if you can put those in the right spot, take a look and see if you can find the things where the order of selecting things doesn't matter. Okay, lottery. Lottery, typically you pull a bunch of balls, but it doesn't matter what order they come in, so they'd be a combination. Your address, mine's 5712. If you went to 5721, you wouldn't find me. And so address would be something where order is important. When you're pulling cards, and there's probably other examples, but like if you're dealt 5 cards, the order that those 5 cards come in typically doesn't matter. So it'd be a combination. Bingo, same thing. The order that the numbers come out typically doesn't matter. If you're selecting teams, if you select 5 people from a group of 20, does it matter what order those 5 people came, or just that they're on your team? Order doesn't matter. It'd be a combination. If you're pulling balls from a bag, you want to pull 3 balls from there, does it matter what order they come in? It doesn't. Your email address, probably be a permutation. Like mine's Jeff dot whatever. But if you spelled Jeff wrong, I wouldn't get the email. So order's important for that. Just in terms of determining whether something's permutation or combination, look for that thing of being order. So here the first question says, how many permutations can be taken from this set? If order is important, it's a permutation as is stated there. There's 5 things, and from those I want to pick 3. Or 5 permutations selected 3 at a time. And you can do that on your calculator. Notice that if you do a combination of the exact same question, but if you're bringing those letters out and it doesn't matter what order they come in, for example, in a permutation, ABC and ACB are different things because the order is different. But if you were to look at them in terms of a combination, these 2 things aren't different. They're the same thing because they each have an A, a B, and a C. So in a combination, there'd only be one of those. So if you want to know how many combinations there'd be in this, you'd say it's 5 choose or 5 combinations of 3. If you do each of these on the calculator, you'll realize that combinations are a lot smaller number. Because if order doesn't matter, if these 2 are really just one thing, there'll be a lot less combinations than permutations. Here's the formula that you can use to determine combinations. Notice that they write it differently. So there's this way of writing a combination, but then there's also this. So if you put something in brackets, like that question on the previous page, you've got 5 letters and you're choosing 3 of them. You could write it as 5, choose 3, and put brackets like that. Or you could write it as 5, choose 3. And you can also put it, if you want, in the formula, where you'd have 3 factorial, 5 take away 3 factorial. And you could figure that out. On Desmos and on your calculator, you can also find it. If you go to functions and stats, there's NCR right there. So you hit the NCR button, and then you put the first number, comma, second number. So 5 combinations of 3 gives you 10. So there's 10 different ways of getting 3 things from 5. And we could probably write them all out. Okay, just for interest, let's see what the 5 pick 3 is. So functions, stats, and PR. Let's go 5, comma, 3. And notice that there's way more. So there's 60 arrangements of 3 things taken from 5. And for combinations, there's 10 different variations of 3 things taken from 5. All right, here's a couple of example problems. So you've got a lottery worth $5,000. I actually just looked at the website, and this week it was $16,000. If you bought a ticket, how many combinations of numbers are there? So you need to know how the lotto works. It's Lotto 649. The 6 and the 49 mean something. 6 means you're taking 6 balls, and 49 means you're taking the 6 balls from a total of 49. So if you wanted to know the number of winning numbers, you would say it's 49 balls, and from those you're choosing 6. And notice that they used to have that Kingo Bingo on Saturday nights in when I grew up, and they had these balls, and they'd pull them out and put them on this little rack. They'd pull them out one at a time, and when they'd pull them out, they'd just order them then. But the order that the balls came in didn't matter. It was just you put them out, and then you just sort them numerically when they got there. I'm interested to know what this is. So how many different tickets are there? Let's pull up our calculator and figure that out. I'll put it over here. Ooh, that's very small. Okay, so I want functions, and I want stats, and combinations. So there's 49 tickets, and from them I'm choosing 6. So there are 13,983,816. So if you choose a ticket, you have a 1 in 13,983,816 of getting the winning ticket. Of course, they have other prizes too for getting 5 balls or 4 balls or 1 ball. I don't know if they have a ticket for winning for 1 ball. Anyway, that's how many tickets there could be. I heard a story, and I don't know if it's true or not, of somebody that went in and they bought all the different possibilities of lottery numbers. So they bought them all. It would have to have taken that much money if they were $1 a piece, almost 14 million, because they were guaranteed to win. Maybe that was just a story, but I guess I wouldn't do that. I don't have that kind of money. Here's another question. So you've got 20 students, and in that students, I'm wanting to select a group of 4. Look at these 2 questions and see if you can determine which one's a permutation and which one's a combination. You can press pause and then figure that out and come back. So in the first question, it says, I want to make groups of 4. How many ways could this happen? In there, it doesn't say that there's any clarification or importance as to when you get called. And so for this one, it would be a combination. So there's 20 students, and I'm choosing 4 of them. Whereas in the next one, it looks like the order they get selected makes a difference, because I get a president, a vice president, a secretary, and a treasurer. So for this, and how many ways I could do that, this would be a permutation, because the order that you get selected depends on which of those jobs you get. So this would be 20, pick 4. So be careful when you're looking at a question. Make sure when you look at it, you determine whether something's a permutation or a combination. Okay, the last question we'll look at is a combination of a couple of different things. So we're going to use the fundamental counting principle, and we'll use the idea of combinations. So here I've got a bunch of people sitting on a board. So there's 5 women, 4 men. And the question is, in how many ways could you make a 4-person subcommittee? So I'm just selecting 4 people to be on this committee. And there has to be equal number of men and women. So I've got to have 2 men and 2 women on this committee. Doesn't matter what order they get selected in, so it has to be a combination. So the way to approach a question like this is to maybe look at just the men and then just look at the women, and then how many different ways that they could happen. So let's look at the men here. So initially I've got 4 men, and since it doesn't matter what order I select them, I can choose 2 of them because I have to have 2 men. And for the women, there are 5 women altogether, and from them I'm choosing 2. So the fundamental counting principle says, figure out how many ways you can do one thing, figure out how many ways you can do the other thing. If you want to know the number of ways of both things happening, then you multiply that result. So the answer to this is how many ways that I could choose a committee. It'd be 4 choose 2 times 5 choose 2. Might as well fire up decimals for the last time in this section. Of course, you got to use decimals in the other sections. And let's figure out what that is. So functions, stats, combination. So I'm saying 4, comma 2. That's 4 choose bracket times. And now I have to do functions again, choose. And I want 5, choose 2, bracket. 60. So if I have 5 women, 4 men on a committee, and I want to develop a subcommittee from that of 2 men and 2 women, there's 60 ways I could do that. Okay, let me do one more question. This is one involving cards. So the question is, how many 5-card hands are there if you have 3 hearts and 2 clubs? And this is very similar to the question in the last one. So I need to look at each thing separately, and then I'll multiply the results. So how many ways can I get 3 hearts and 2 clubs? So how many hearts are there altogether? Here's the hearts. If you count them up, there's 13. So to get the hearts, there's 13 of them, and I can choose 3. That'll tell me all the different combinations of 3 hearts in your hand. To do clubs, you do something the same. So there's 13 of them, and you're wanting to choose 2. So if you want to figure out totally how many different 5-card hands there are that have 3 hearts in them and 2 clubs, you would multiply that result. So 13, just do it on your calculator, 13 choose 3, and 13 choose 2. Okay. So in this video, we've looked at combinations, found that they are selections where the order that you select things in doesn't make any difference. And that's an important point. Make sure that when you look at a question, first determine, does order matter? If it does, it's a permutation. If order doesn't matter, it's a combination.